So hi everyone. So I'm Charles Villiers. I'm a geotechnical engineer, and I'm also involved in tailings management. So today we just want to explore or share with you our view on tailings management. So this is here how we see a tailings storage facility, or it could be. So basically, we don't want to see tailings or waste rock as waste, but that as a resource. So this is why we've got that photo here, which is a quarry, basically, with sorted material for construction. Now, this can only be achieved, or for this to be achieved, we've got to make sure we have, these key steps. Okay, so one of them, we've got to make sure that we put this cross-industry collaboration. We really need to develop that further. Then we've got to make sure that also we adopt a long-term vision on that waste management as a resource. Okay, so basically, when we start a tailings project or we're about to close, we've got to really all the time think resource. Okay, so that's really a mindset we need to change. Then also we need to also consider the cost of a tailings dam failure. There are regular failures with various level of seriousness, but it's a cost, and that cost is rarely included into the financial model. If it is, and we realize that recycling would be a very strong option. So also we need to really make sure that we have political support, whether it's locally or internationally. There's a need for countries to adopt or to really promote that system. And also we've got to make sure that these solutions become included into industry standard. Like if we have the global industry standard should include options like that. That's what we want to see, that more and more. If we have that included, then we have a better chance of achieving serious volume reductions. No, synergy exists, yes, because in mining, for example, at the moment, the current global production of waste is about 90 billion tons. Of this, is about 80 billion tons is waste rock, 8 billion tons is tailings. And then of that, we can compare these to construction, for example, where they consume about 40 billion tons of aggregates every year for construction. And there's about 4 billion tons of cement being produced every year. And this, aggregates, that means quarries. Quarries means disruptive the environment. There's a lot of issues related to this. And sand, at the moment, mining sand is becoming more and more difficult. And then farming, we can consider farming also. So every year there's close to 100 billion tons of soil being washed away, fertile soil being washed away. That really creates a lot of problems for poor countries. So there is here also a potential synergy for repurposing some of the material that we create. Now, this is also an example of international collaboration. So as a circular mine, so we're collaborating a lot with Europe, because in Europe there's a lot of expertise, and that's by necessity of recycling, because it's an area, or there's not enough space basically. So there's a lot of different system collaborating on the same space. So talking about industries, still mining, farming, tourism. So they have to really be very careful about this. So they're very advanced. So we're collaborating a lot with them. And that's really helped us. There are a lot of interesting solutions there. One of them is a French geological survey, BRGM. Another one is Austmine, for example. It's a leader in a construction material, concrete, global. Then this is, sort of typical options. So construction, we go to aggregate, cement, backfill. Agriculture, we can create technosols from that. And from this technosol, then we can create some form of farming activities. And all that can be, in some cases, not all the time, but it can be related to also the carbon market. So which means you can do carbonation of some of the aggregates. And then you can create also some plantation that will also foster carbon capture. And then the other consideration out of this is, and I think it's a really positive option, is actually we also remove a cost related to risk of failure. And also, we've got to keep in mind that the value on a product, even if it's far away and there could be some high cost to transport, there is actually, it may be the case of today, but in 10 years' time, it may not be. So we're creating future value as well. That's a possibility. No, this is just a typical process that we do or we advise. So there's first, tailing characterization. Then there's all the time a decontamination aspect. Then from this, we can also, from the clean tailings, we can look at what are the different options. And also it can be related to the local market. Then we can classify them. Then we can look at carbon sequestration. Then there's also, we need to create then these products. We need to test them. Then from this, when the industry partner feels that we have something which has a value, then we can look at process modeling. Then we can define financial and carbon production and construction costs. So we can define all this, make sure it's taken care, it's really considered. And then we have then to confirm the interest from the industry partners. Then we have to make sure that the product gets approved. Then we build the tailings recycling facility and then deliver to the market. Now, in conclusion, we can say that the technology already exists and is available really to recycle the tailings or the tailings, and also to remove the need for tailings dams. It should also be systematically considered at all stages of the life of the mine, including closure. And also, it's really important that now we break that long cycle that we had about disposing mine waste in the environment without even considering what value it could have for other resources. Thank you very much for your attention.